Lesson 7, the inverse and contrapositive of conditional statements. So an inverse negates both the hypothesis and the conclusion of a statement. So, for instance, if you had a statement, if a number is even, then it's divisible by 2. The inverse would be, if a number is not even, then it is not divisible by 2. Contrapositive is negating the converse of the statement. So not only do you make both of them the opposite, you also flip them. So again, with the number being even and being divisible by 2, we would flip it and make it negative. So if a number is not divisible by 2, then it is not even. So lots of double negatives and a whole bunch of confusing stuff, so you just have to be really sure about thinking through this to get your answers, to see if it's true, to see if it's false. So, for our first example, if today is February 29th, then the year is a leap year. So for A, we want to determine the conditional statement, and it already has that. If today is February 29th, then it is a leap year. So our hypothesis, P, which is if today is 29th. So we're going to assume that that is true. The conclusion is it is a leap year. So this would be Q. And if it is the 29th, it has to be a leap year. So that would be true. So P to Q is true. B, we want to find the inverse. So the way that we show this is not P. And that's the sign for not P. So not P, then not Q. Oops. And we want to see if that's true. So if today is not February 29th, that would be the negation of our hypothesis, then it is not a leap year. So the first part's true if today is not February 29th. Now we need to know if that's true or false. So what that's saying is today is not February 29th. So that means it's the days 1 to 28. It could be any of those days. But we have no idea if it's a leap year or not because you could just not be on that day yet. So say you're on the 28th. Well, what if tomorrow is the 29th? Then it is a leap year. So really that doesn't tell us anything. So we know it's true, then false. So that means our total answer is false. So altogether it is not a true statement. And last we want to do the contrapositive. So what that is not Q, then not P. I just made a square root sign. So if today is not, if it's not a leap year, we don't have to say today, then it's not February 29th. So we know it's not a leap year. That's our true statement. Then it's not February 29th. Now, because a leap year has to have a February 29th, we know that that's also true. It can't be February 29th if it's not a leap year. So not Q to not P is true. So for this one, our contrapositive statement is true. So example 2, if a number is a multiple of 10, then it is a multiple of 5. So determine conditional statement and the contrapositive statement and determine if it's true. So this is our P, if it's a multiple of 10. Our Q is if it's a multiple of 5. So we want to find if that is true. So P, then Q. We know that P, if it's a multiple of 10, has to be true. It's giving us that information. If it's a multiple of 10, not 2, it is also a multiple of 5. We know that because every multiple of 5 that ends in a 0 is 10. So we know that that's true as well. So this is a true statement altogether. The contrapositive would be not Q to not P. So we'd say if a number is not a multiple of 5, so that would be not Q, then it is not a multiple of 10. So now here's our contrapositive statement. So we know that P, or Q, if it's not a multiple of 5, okay, that is true, then it's not a multiple of 10. So all multiple of 10s have to be a multiple of 5, so that is also true. So altogether, our statement is true. So our contrapositive statement is true for this example. Example 3. If a color is red, yellow, or blue, then it is a primary color. So this is P, this is Q. Primary is our Q, red, yellow, blue is our P. So our conditional statement, P, then Q, we know that P is true because it's telling us if it's red, yellow, or blue. Then it is a primary color. That's true. Red, yellow, and blue are all primary. So our conditional statement is true. B is our converse. So we do Q, then P. So if a color is primary, so we should write this out. If a color is primary, then it is red, yellow, or blue. So if a color's primary is true, then it is red, yellow, or blue is also true because all of our primary colors are red, yellow, and blue. So our converse is also true. The inverse statement is not P, then not Q. So if a color is not red, yellow, blue, then it is not primary. So our not P is true. We know it's not red, yellow, or blue. Then that means it is not primary, which is also true. Because only red, yellow, and blue are our primary numbers. So altogether, this is a true statement. And determine if this statement is biconditional. So for D, that is when your converse and your conditional statement are the same. So it's the same forward as it is backwards. So because this and this are equal, this is biconditional.